Okay, we start in
2 minutes, okay.
1 minute and 10 seconds, approximately. Let me check that everything is okay. 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 Okay, I will switch the video. Okay, let me start in 3, 2, 1, and go. Hello, hello. Good evening, everybody. Welcome again once for one more webinar from our company. I'm Spiros. Nice to meet you. For those that don't know me or haven't had the chance to meet me personally, I'm the technical trainer of Medit for EMEA region. I'm responsible for the training of partners, and also I'm providing technical support to all our partners within the EMEA region. I would like to welcome you again, and I would like to apologize for last time. We had some technical difficulties for the sound, and I think this time everything works perfect, so we won't have any issue, and we will enjoy an amazing webinar that we have prepared for you today. So today we have the honor to have with us Dr. Karsten Kamm. Dr. Kamm, thank you again for being with us today and joining us in our webinar.
Yep, thank you. Okay, then we can start.
Yes, yes.
Okay, we play. So, hello everyone. Welcome to Digital Dentistry. My name is Karsten Kamm. I'm working in a private practice in Germany and at the University of Digital Technologies in Medicine and Dentistry in Luxembourg. What are the possibilities today and what does the future look like? I will show you in the next, I think, round about 60 minutes, my future of the digital dentistry. This is the outcome for today. Where is dentistry or dental technology in digital workflow today? Do digital systems open us new application areas? What is the future of digital dental technology in teamwork? Many thanks in the first time to my complete team in Baden-Baden. Without my team and my technician, we cannot create a perfect digital smile. We are presented at 2 locations in Baden-Baden. We have been on the way in the digital world for, I think over 20 years. We started in 1998 with our first milling machine. It is called the DCS machine from Switzerland. It was a long way from this machine to our daily work now. First, we started with the CAI, computer-edited impressioning. What are the benefits of CAI? We have now the control of the preparation geometry. We can see all things, but we can also see all our mistakes. We can see the preparation margin, the height, the direction of insertion. With these tools, we have quality improvement. Also, we can make coloring digital. But the selective correction is possible. This is the most important tool for me in the way of intraoral scanning. In a clinical study of Mensa of dimensional stability of digital full jaw impressions and the development of a new Mensa methods, we can see that the intraoral scan is in the same high accuracy as a normal impression. My colleague Kur placed 4 bullets with an extra splint into a mouse. You can see this here. With the GOM Inspect software, he analyzed the accuracy of 6 intraoral systems in the year 2018. The accuracy you can see on the picture with the GOM Inspect software. You can see this here. The middle, the accuracy is green, and you have negative in this way and positive in this way. And you can see on the bullet the accuracy is very high with the intraoral scannings. What do we stand today in the digital dentistry? We have automated production enables more cost effects, production, and thus enables compatibilities. Access the new virtual defect-free industrially prefabricated restoration material. We used in our practice zirconia monolithic type 1 to type 4. We used lithium disilicate. Sometimes we used zirconium reinformed lithium silicates. We have high cross-link polymer. And last but not least, we have new metals we were manufactured by laser melting. But on the next step, what are the benefits of CAI? Maybe the patient comfort, not the first benefit. Correctable of impression selective, that's perfect for me. Reproductively of the data. Sometimes I show you in the next minutes, we have new treatment concepts, but we have a direct communication representing in real time with the patient or sometimes with the technician. I've told you we have direct quality control. We have analyzed options of the preparation and restorations. We have the shade taking, data matching is possible, and so we have new treatment concepts. And last but not least, we have the evaluation option. If we scan a little child, maybe 15 years or 20 years, and if we make 10 years later or 20 years later a new crown, we have the data of the very good tooth in the age of 15 or 20. That's the possible for us. But if we have benefits, sometimes we have disadvantage. What are the disadvantages of CAI? Sometimes we need at the beginning a little learning curve. That's not the problem. We must have scan buddies for all implant supplies. Maybe for the big players, we have all scan buddies. That's not the problem. But sometimes we have little manufacturers of implants, and so we need also for this implants scan buddies. Maybe that can be a little problem sometimes. We create the static and the dynamic occlusion. The accuracy of full arch restoration is not so good as the accuracy of a quadrant. Sometimes use we closed systems. And now the accreditation costs are in Germany. I think we have the cost from 16,000 up to 45 to 50,000 euro. Sometimes scan inaccurate depending on the user. I've told you at the beginning we have a little learning curve. Maybe powder. I think the new systems doesn't need power for the intraoral scanning. And now we used the Medit i500, I think, since 1 year. What are the benefits of the Medit i500? We have powerless. The use of power is not necessary with the scanner. We have maximum flexibility, open system for easy export of SDL or maybe OBJ data. HD resolution in color, realistic detail imaging of the oral cavity in color. The impression speed is very good, fast and efficient scanning with 2 high-speed cameras. And the using. We have a narrow and stereo blade scan type, easy handling due to a light hand sweep, and it's well fit in the hand. I think I can use this tip 10 to 15 times. We can sterilize it, and after 10 to 15 times, we use a new tip.
20 basically.
20, okay.
20 times. Yeah.
Okay, we can 20.
And sorry for interrupting you.
Yeah.
I would like to let you know, everybody, that in the near future, we will release also a series of tips that they will last for 50 times.
Okay, that's good.
It's the near future.
And what can we say about the high accuracy? The accuracy is 4.2 micron, and the precision is 2.1 micron. And you see here, I've told you, if you make a single crown, you have very good high accuracy. 5.3 trueness and precision 3.2. And also the full arch is a little bit not so good. We have, but it's good. We have 21 micron in the trueness and 22, 23 for the precision. It's very, very good for the intraoral scanning. We have with our Medit scanner many features. For example, the impression scan. This function supports composite scanning operations with use both embossed aura scan data and engraved impression scan data. With such a simple scan, both data can be matched in real time and used for modeling for the technician. We have a pre-scan. We can perform a pre-operation scan of the patient teeth and usually this data for a warranty of use. With this pre-operation scan data, the post-operation scan be performed more quickly and easy. For example, we make a full arch scan, and in the next 2 days or 5 days, we make a preparation. And after the preparation, we only must scan the preparation teeth and not the full arch. And so it's quickly and easy. The data can also be used as reference data in the modeling process to assist in your creating more and natural prostheses. So the next features we have with the Medit. We have the margin line creation. iScan features automatic and manual margin lines creation as well edit functions. While scanning a patient, you can add or edit control points on the prepared teeth scan data in order to draw the most accurate margin line. That's very good. The create margin lines will be forward for more accurate prosthetics designs and production along with your order. The next feature is abutment and scan body matching. The function allows you to match scan abutments and scan bodies, such serving time in instance of poor scanning environments. You can select the appropriate library for each tooth. When you scan the corresponding tooth, the scan abutment and scan body are automatically matched and aligned with the scan data. The aligned library data can be used for downstream work such as design. A manual alignment point is also available. So we have first video. You see a scan of perforated tooth in the lower jaw and an interoral scanning in the upper jaw. Implant prosthetic is one of the areas where digital impression is a great relief for the dentists. The transmission of the implant situation in the mouth has been uncomfortable and difficult for patients and physicians using conventional methods. When you scan the corresponding tooth, the scanner button and scan body is automatically matched, I've told you. You see in the video the perfect margin after the scanning. The next one is the occlusion analysis. The occlusion analysis is very helpful to check the possible thickness of the later supply of the crowns, for example. Prepare the substance material especially. You can use, must I take a zirconia material or can I have desilicate material? The next feature is the scan replay. The scan replay function allows you to replay previous scan process. By virtually showing the scan tip and scan area, you will be able to see how it's scanned, enable you to identify it and improve your scanning methods or habits. I've told you, you have on the first step a little learning curve. And so if you see in the scan replay what you have scanned and what are your problems, and after you analyze the problems, you are in the next scans more and more quickly. And this is a very good tool for this. So I'll show you a video of the occlusion analysis. This is very helpful to check the possible thickness of the later crowns. The occlusion analysis functional quickly analyzes the occlusal state of the maxilla and mandible, displaying the results in a color map with numerical values. The color map shows the degree of occlusion in different colors and displays the corresponding values when you move the cursor over each other. You can see if you have 1, 2, 3 millimeter space from the upper to the lower jaw. Oops. So we must change the slice.
In the meantime, everybody, whatever questions you might have, please feel free to write on Q&A so we can answer them in the end together with Dr. Kamm, or even me if I can answer it, of course. Thank you.
So I will show you a little video of a full arch scan. This is maybe for a lower scan, for lower jaw. This is real time. You see a normally scan. I make it a little bit quicker. I think I need 1 up to 2 minutes for a normally scan of a full arch with the made it.
Yeah, usually an experienced user needs about 2 minutes
2 minutes.
per
Huh?
arc.
No?
Per arc.
Yeah. I think it's the same for me. Yeah, and you can make this as a pre-scan, I've told you.
Yes, as a pre-op. Yes, we can use the pre-op, of course.
Yeah, and you have this data before you prepare a tooth. So I think this was a scan a little bit more than 2 minutes for this. So I show you another video for the scan bodies. Six. Oh, that's 6. Okay. Deeping on this in the systems, the rest of the jaw is first of all of the open implant screw is displayed the emigrant's profile. The transmission of the emigrant's profile is an information that was not available to the laboratory and functionally as well as aesthetically superior results are possible. Subsequently, an implant system and implant size matching scan post-screwed into determines the implant position to transfer. This is also scanned. The software of the scanner automatically includes in the first scan. Now, subsequently, an implant system and implant size is appropriate scan post to adjust the implant position transferred. This will also be scanned. The software of the scanner automatically incorporated into the first scan. When applied in implantology, the elimination of individual components such as impression posts, laboratory screws, or laboratory analog adds and additional these are economical factors for me. So the next step, I think, in the future is the new 3-in-1 abutment. Some companies make now one abutment is a healing abutment, it's an impression cupping, and it's also an scan body. The code on the healing abutment is provide 3D informations. Now you can see here you have on the top all information for the scanner or for the software. You have provide 3D information. We reduced abutment swapes, aesthetic outcomes, full digital workflows, and laboratory design products are patient specifics. Allows you more control over restoration for better aesthetic and functional outcomes compared to traditional procedures. We have no abutment sweeps. Sometimes we have an implantation, and then we have a healing abutment. Then we make an impression coupling, or we take scan body. This was the old way. And the new way is the 3-in-1 abutments of some companies. We see on the left picture the pre-scan compared to the scan after the preparation. This was the first scan in this area or in this area, and we make 2 days or a week later a preparation, and we only scanned these areas. And so we have all information about the teeth of the first pre-scan. In this picture, we can see the detail and accuracy of the scan in the area of the preparation limits. Of course, the area of the preparation limit must also be visible during the intraoral scan. It's always the same as the normally impression you have made before. The scan must see the margin line, the same way as the conditional impression. We worked here with a double suite technology, and in difficult areas under the gingiva, we use the electrosurgery device after preparation. You can see this here. We have one street, and sometimes we need a little electrosurgery device. But you must see the margin. If you don't see the margin, the scan is not correct. The scanner cannot see under the gingiva. It's always the same as a traditional impression. The next step in the future is the face scan. With the face scan, we can now transfer all functional levels to the CAD software. We are now able to create a real virtual wax-up or mock-up. For the first time, real dental imaging is possible. If you have only 2D photography, it's not so good. It's not possible to make a really real dental imaging. How do you now transfer the How do you now transfer the face level from the patient using the facial scan? In the first step, we position the patient in the plane finder. You can see here, this is the plane finder. Then a scan takes place in this position. In the plane finder, the patient always positions his head in the horizontal plane. This position is always reproducible and corresponds to the plane in the articulator. It's the benefit of this system. The patient can go out, can go into the plane finder, and they find in any time his correct position in the horizontal plane. Following this, further face scan can be made once with a closed mouth, a lost, and an open mouth. You see the open mouth. With the open mouth, you can see the occlusion levels. The scan works via a 2-point matching. At the end, we use the transfer fork to scan the position of the upper jaw. In an extraoral scan, the impressions of the upper jaw teeth can now be scanned and everything can match together. And so we have a perfect smile for the patient. We can now determine all lines in the face and transfer it to the occlusion. This is interesting for toothless patients who are not being provided with complex implants and reconstruction. The 3D face scan data bring both dental technician and dentists as also the patient a number of benefits. While the technicians are creating restoration based on the face and such with much higher planning, reality can work, get the dentist a nearly photorealistic preview of the final results. Now you can see in this picture the ala tragus line. This is the line. Yeah, the face is in the right position to the horizontal line. The next step. This is the first time you have the possibility to function according to function analyzed occlusion levels at the computer patient-friendly worked. This is a new approach to transfer individual patient information, like national head position, ala tragus plane, I've called, this is ala tragus line. For exact determination from occlusal plane. We have all natural symmetries of the patient, as well as the aesthetic position of the patient increase the quality of the reconstruction. No? You can move, for example, the ala tragus line here to the occlusion. And so you can create a perfect upper jaw. So the next step. So I show you a construction. Every technician is happy if he can see in his CAD system the face to his construction in the corresponding registration. So it can create highly aesthetic reconstruction for all facial proportions. Now you can see if you have all informations of the patients, of the face.
And also, I would like to add that we have a feature which is called face scan in our software that allows you.
I have two pictures later.
Perfect. Okay.
No? I have two pictures of the medits. This is an extraoral face scan, but
Yes.
as Piro says, it's very correct. We can make a little face scan also with the oral interoral system from medit.
Or even from the bone data that we have converted in STL, you can also match them with the face scan and your intraoral scan, also within our scanning.
Genau. You have the first step. If you have now a face scan, you can make it with the interoral scan from medit. You can make a very good little face scan. I show you some pictures later. So. Now you can see it, no? This is the medit way. No? We performed normal interoral scans. And after that, we scan with the medit also the area of the lips. Now you can see this. We have a normally scan. We have a normally scan. And after that, with the interoral scan from medit, you scan the lips and the nose. And in the second step, you can combine the two scan with the facial scan. No? You have this one, you have combined both. No? And in addition, if you have a face scan, you can also add the additional face scan to the normally scan data of our interoral system from medit. No? It's the same way.
Also, for those that would like to have a facial scanner, they can do it also with their smartphone, especially if they have a latest generation of smartphone with very good resolution on the camera. You can download some applications that allow you to have a facial scanning of your patient, so you can include it in the therapy and basically in all the treatment plan to match it with our software, the intraoral data, and so on.
Yeah, that's correct. So the problem, if you have a face scan, you must match the face scan with your teeth. That's maybe the problem. And if you have an intraoral scan, the intraoral scan system match both the scan of the teeth and the scan of the lips and the nose, and it's perfect. And you have no problems to match a face scan with your extraoral scans of the model maybe, or with the intraoral scan data. So the next step is 3D plans matching of data. Normally we have, as Spiros told you, we have a digital volume tomograph, we have DICOM files with the data of an intraoral scanning system. You have STL files, maybe OBJ files. With the face scan, you have OBJ files. You have normally STL files, and on the top you have some information about the color. And so you have quality improvements. And now you can, with this all data, you can make a very perfect backward planning. So the next video shows you a 3D view. We have a patient without teeth. In the first step, we make a total prosthesis and took functional measurements. We use the plane finder and the face scan to find the planes. The patient got screw bridges on bars in both jaw. And now you have the perfect bite from the upper to the lower jaw. But you need a very, very good functional system, and you need a face scan. We must change the slice. So part 3. So where do we stand today in digital dentistry? We have digital imaging like Coachman, DSD. We can make aesthetic analysis. We have a perfect intraoral scan. We have more and more face scans. Spiros says you can make your face scan with your iPhone, maybe.
Yeah, also.
We have some companies who matched this data with your intraoral scans. It's very perfect. And if you have all this information, we can make a very, very good backward planning. And it's more and more easier for the surgery to make a very good positional office implants. And after we have very good positioned implants, we can create a perfect smile. We can create perfect crowns and bridge over the perfect size of the implant, the perfect position of the implants. And the next step we have used is the virtual articulator, is matching DICOM data and function data. In this way, we use the freecoder. I show you a little experiment video we have made. Now you see we have matched DICOM data with intraoral scannings. You can see here the upper and the lower jaw, and we matched on the top the functional data. Now, in special software, this is a Blender software, this is a free software. We don't have to pay for this. You can get Blender for free. Now, and so we matched all the data we have. DICOM, functional data, we can select. Now you can see your movement of the joint. Now, and that all with a free software. Now we can select and yeah, now you can see the movement, not in the jaw, as in the joint. You can see the movement in the mouse. You can see the movement between the upper and the lower jaw. You can see the perfect contact points. Now, if you close, it comes. Yes, you can see more and more contact points. Okay, the next step. The next step I've told you was backward planning. What does the digital workflow in the implantology look like today? Data acquisition. We have DICOM data from the digital volume tomograph, DVT. We have SDL data, I've told you, from the intraoral scan. We have the clinical situation in the form of an intraoral or a model scan. We have face scan data, and last but not least, we have functional data. I'll show you the next video. This is a video of implant planning. Now you see a normal planning of an upper jaw. Yeah, we have all informations. We have the information of the bone. We have information about the plane. We have a library for the implantation. And so we can position the implants virtually perfectly in this position. Now you have seen, I go a little bit back. Now this is backward planning. Oh, you have the construction for the new bridge and crowns. And now we can make a perfect position of our implants and create a screwing spline. So, but sometimes we have problems with the position of the national teeth. And now we have always the digital way. We can make pre-prosthetic orthodontics. We can use the aligner technology. I'll show you a little video. Now you can see we can move the normalities in the correct position. This is the digital way. We use the aligner for this way. We make an intraoral scan with the MEDIT, and after that, we make 3D printing models, and then we make the aligner technology. Yeah, I've told you the prosthetic plannings we can make with the face scan, the intraoral scan, and the matching of the data, a virtual wax up. We can make different variations for the crowns and the bridge. We can discuss this with the patient, with the technician, and the patient see the results before we begin the production of the crowns and the bridge. I'll show you a video of the face scan. Now, you have a patient, you have a face scan. Now we can create a backward planning. Now, this is our construction. Now, this is our crowns. Now, in the next step, you can see the national teeth, what we must make. Okay. Now you can see the problems. So, and now we can see an implant planning. We have all details of the bones. We have the old situation. And so you can create a perfect position for your implants with the full digital way. Where do we stand today? Let's talk about communication. We use a 3D PDF as communication tool. Every technician can create a 3D PDF with 2 clicks. I'll show you such a 3D PDF. And for the technician, it's only 2 clicks. And that's communication between the dentist and the technology, or the patient maybe. I think Adobe Reader has everyone on his laptop or PC.
Yeah, usually I make sure to install it in case I'm doing an installation to somebody. I know that Acrobat Reader will be needed for that purpose. Also keep in mind that we can also print the prescription of the orders through our system in MeditLink.
Yeah, it's, I think, 2 or 3 clicks, not more.
Yeah.
If you have a perfect construction for the technician, maybe 10 seconds, 15 seconds, not more. And you have perfect communication tools between the patient, the technician, and the dentist.
And now we have also the share tool through MeditLink from the web application that you can share with a PIN code, so they will be protected everything to the patient. And also you have the share tool that you can use with the lab to share and talk about the case. So for the clinicians, there are 2 ways that they can share the data, one with the patient and the other one with the lab.
Yeah.
The only difference between them is that whatever has to do with the patient requires to provide to him or her a PIN code in order to be able to see the data for protection.
And I think it's the best way. If you have more communication with the patient can see our construction, and he can say, oh, it's good. So I can say, oh, maybe make a little different here in this way or in this way. And after we have correct our construction, we have a perfect construction.
Yeah.
And I think that's the way we make communication with the patients in the future, now and in the future.
That's very important.
Well, and the digital dental vision, that's the future. The future may be augmented reality. Refers to the overlay of real-time images with additional digital information, and such leads to an expansion of the real environment. The system that runs interactively in real time. For example, you can see this on this picture with the cups. You see left the normal cup. So you can see here the normal cup. And now in the middle, you see the mixed reality. Now you have another form of the cup. And now we have the virtual reality. We have augmented reality. So augmented reality, I have a video from my colleagues. You can see here. It's from IR Society, Digital Dentistry Society. And that's the future. That's augmented reality. Over a glass, you get all informations of the bones and so on. And this is in real time. These systems use an ultrasonic system. Maybe you have systems with cameras.
I saw a system like that in Italy, and I was really amazed about how the
Mhm.
system works and how accurate and easy it is. Because I had the same question to the clinician that he demonstrated to me, and I was like, "How you know that everything is correct and everything is aligned and nothing is wrong?" He said, "No, don't worry, everything is properly calibrated, so we can just
Mhm.
do our work, and
Genau.
then we have guidance like that."
Yeah, you have this camera systems, and now
Yeah.
you see the position of the implant, the drilling, the green. No? The green shows you the drilling is perfect in the line. No? You can see this, the perfect implant.
Yeah.
Okay. And for me, in the future, in the prosthetics, I show you now with the video. With a special software app developed by the company Campanu in Switzerland, we are able to visualize a possible situation for patients. For this, we use only an iPad. No, the patient looks in the camera of the iPad.
That's also very nice and very interesting.
No? The patient is looked at the iPad, and the movement we can only show individually construction situation. I think we can adapt these pre-construct forms. We have, I think, 6 or 8 pre-constructed forms in this time. So we can vary size with individual inclination of each axis and curves, no? And the patient can move his face. No? These are the prefabricated constructions. The patient can move her head in all directions, and the construction situation adapts. Currently, everyone knows maybe Snapchat. Our kids works with Snapchat. It's the same.
Also, keep in mind for everybody that he might be interested that we can combine everything that we have in our software, and also we can align them in an occlusal plane. We have a function which is called aligned occlusal plane. So
Mhm.
in case we have the data, we
Mhm.
can align them properly according to the occlusal plane. So if our dental lab is using
Mhm.
exocad, they have already aligned everything from our software, so they don't need to do anything at all. And
No, I think that's the next step.
yeah, and helps a lot this function specifically with
No? No?
the facial smile design.
No? You can move the plane, the lines, the axis. No? But in this moment, we have only 6 or 2 forms in the systems. No? And the future is that we can real-time tracking of our construction data in these systems. Then we are perfect. No? You can create with a pen a little bit. You can change the forms a little bit. No? If you change these forms, you can get these forms or match these forms in the face scan or in the real-time video of the patient. No, I think that's not normally, but I think that's the future in 2 or 5 years, maybe.
That's interesting. This app, maybe I need to check it also.
Mhm. So the next one We're going back to the slides. So the next slide. So the next one. So I have a little video. So, okay, going back. We have seen it. So, okay. The next step, how we create the perfect position of our implants. The first guided surgery module system. We're working with a modular drilling template system after the virtual planning. We have first plinth is fixed on the bone with 3 or 4 pins. Well, this is the first plinth. And you have 1, 2, 3, 4 splints maybe. And you have a perfect position now. This is a perfect position we have created with the virtual planning. And on this, we have a second spline. It's snapped onto the first spline. Now you can see here. Now, with this spline, you can see where in the future the bridge or the crowns are in the positions. Now you can see your complete area for the surgery, and you can remove this. The next step is this. This is a third spline. It's a guided drilling template. This spline can be exchanged on the basic spline at any time for a perfect fit. And you can change. You can use the guided drilling template, or you can use the other one. You have you can look in all areas. The problem with the guided drilling template for the surgery, maybe he cannot see what he make, but you can change the drilling template to the normal template, like this way. Now, it's the next step. The next step, if you have temporary restoration, can be also placed on the base spline and bonded on the abutment of the implant using normal polymer materials for a perfect fit. This is our temporal dentature. You can see the perfect fit over this. And you now you can paste it on the base spline. And then you fixed your maybe multi-unit abutments for your implant system with using polymer materials. And so you have the perfect position of your temporary dentature. And after that was finally definite restoration You can make it with, we make it normally with zircon. Sometimes we used PEEK as a base, but normally I think 80 to 90% we used for this final restorations zircon dioxide. Well, the same case, another case, but in this case we have more vestibular veneered worked in the lower jaw. And this is our way we make digital dentistry now and in the future. So what are the take-home messages for you? Where is dentistry? I've told you where is dentistry or dental technology in digital workflows today. We have clinical long-term studies show good survival rates of CAD/CAM produced dentures, access to new virtual diffract-free restoration materials, I've told you, transmission of functional levels through the face scan, and you have the perfect lines for all restorations, increase in quality by intraoral scan in single supplies and quadrants. That's perfect, I think. You can, with an intraoral scan, make a totally digital workflow with single supplies and quadrants, and maybe full arch is coming more and more. We can combine facial and intraoral scans, I've told you. No? We have talked about, do digital systems open new application areas? I think so. Real virtual wax up and backward planning is now perfectly possible. We have guided surgery virtuality, I'll show you in the video. And we have new dental full digital workflows. In the future of digital dental technology, complete digital workflow from imaging to production. I've told you or show you videos about augmented reality, transfer of a wish of the patient directly into the construction. That is the future in the next 2 or 5 years. Okay, thank you for your attention, and I hope you enjoy in the next days your perfect digital dentistry. Thank you so much.